thanks for having me. Thank you for the kind invitation for coming here to talk to you. Now that we talk, I already said before, and these last 2 weeks are like crazy, so I'm a bit in the middle of a lot of things. And now that you were introducing me, I only realized that I did not put my typical slide as a second slide, which would explain my background. So I'm trying to do that without the slide now, which should be possible. So as Annika has already mentioned, I'm the head of the Vortex lab, and we do basically 4 different kinds of things, I would say. One thing is that we provide introductory material to people who are in the humanities and want to do an introduction or start, or maybe have started and go deeper into digital humanities. So that's Vortex.net. That's a portal that has been also enhanced now by a journal that does a low threshold introduction to tools and methods that are used in digital humanities. It's in German, so that's a thing we do. Another thing is that we are the maintainers and developers of the annotation software CATMA, which is an open source collaborative software we also use in our teaching and research, as well as other people, so it has like 20,000 users. And the third thing is that we do what you probably would expect if you hear about somebody who does digital humanities and literary studies, which is text analysis, basically. So we analyze text and look into text by using computational means. Currently, for example, we look at animacy or conflicts or also eventfulness. So these are things we try to tackle automatically. And the fourth thing is the thing I'm talking about today, which is basically, I often say just is theory, but not theory in a theoretical theory sense, but more things like methodological issues, operationalization, all these things that are extremely relevant in the digital humanities, because I think it's because they're a field that's not as old as the established fields that do a lot of formal stuff. Like, for example, also computational linguistics is, I think, a proper example for that. But many other fields where this turn towards quantitative approaches is like some decades old or even older, or has always been there, one of these. So those fields typically have not the problems we do have, because we are still like only, I don't know, 40, 50 years young. So, okay, that's basically the background of what I'm going to do today. So theory versus computation on building many bridges over the gap is, I will try to actually to put a lot of things in the next half hours, maybe too much of them, but maybe, so that's an offer of for you also, and I hope from my side that you will pick out things that you're interested in talking maybe about more after that. So the first thing is that I will try to extremely quickly talk about literary text analysis as an input process output workflow, which of course is a bit unusual. Then I will talk the major part of my talk about the role of computation and theory. So I will not talk about computation and theory, but I will talk about the role of those both things by the examples of computation literary studies, which is, as I already said, my main background in disciplinary terms, and a specific subfield of that, computation and narratology. Then I will point out the gap in the process, or one of the gaps in a process, but it's maybe one of the most important ones, and propose very, very quickly and draftily at the end a more complex model for input process output workflow. Okay, so literary text analysis as an input process output workflow. What's that? I mean, I think I don't have to explain here what input process output workflows are, but nevertheless, I will just go quickly through that and say it can be seen also generally in theory about science as a most basic structure for describing a process by dividing those 3 parts of it. And in computational processes case, it is something receives an input, does some computations on it, and returns the results. It's that easy for now, at least. But still, there are 3 challenges. And the third one is a challenge that's specific for literary studies, or at least that's a challenge that's quite a challenge for literary studies. But I actually think it's also a challenge for many other fields. So first thing is that the system is separate from the environment. So there is no communication between them. And this means that there's no adjustments during the process. That's a problem in most humanities fields, because we do process our stuff discursively, right? So, and of course you can say that discourse is also a process, which is true, but it is still not defined beforehand, which would be necessary if you do a process, right? So that should be repeatable to a certain extent, even though, of course, as you probably know better than me, the output will not be reproducible in any case, because if you go with stochastic things and all these things, every time different things happen. But it should be describable in a very clear way. Right, so that's basically, I don't know who of you has a background in humanities or even literary studies, but I can assure you that this is definitely not a way people look at literary studies. But this is definitely a way we should look at literary studies if you do computational literary studies. This is definitely a way we should look at humanities if you do digital humanities analysis, right? It's not about if you do things like preparing editions or work in the archives and all these things, then it might be a different issue, but if you do analysis of texts and other artifacts, that's important. Right, so what I said with many words now is written here. Literary text analysis is a complex process. Why is that? Well, it is because text analysis, it's also a wording problem, of course, because text analysis generally encompasses two things. One is analysis and one is interpretation. And that's why I always say text analysis in literary studies is basically a black box, right? So in order also to juxtapose it to the computer science thing where people say, yeah, these algorithms are all black boxes, or at least what they do and how they produce results, especially, for example, at the moment in the case of generative language models. Right, so it's a black box, but it has two parts that go in. We can talk about, we have the part of the analysis, which is basically like a preparatory step for the interpretation. It helps people develop a primary understanding of the text, and it assigns meaning to texts in very small portions. So it's not the overall sense of the text, it's mainly the meaning of the parts of the text. Whereas interpretation is based on this and then provides a overall hypothesis, at least, about the meaning of the text as a whole. So there's also some additional stuff that comes in there, some extra textual factors and other things. You may also relate to context, you may relate to readers and all these things, depending on the theory actually you're using. But this is not a topic for today, right? So the thing is, if we look at literary text analysis as an IPO, we can say it is input is literary text or texts. The process is the analysis, as I have tried to extremely quickly describe just before, and the output would be an interpretation result. And of course, like every IPO pattern, there is sub-patterns of that. Of course, analysis also has a kind of an input, a process, and the output again. Same holds for input and output, and same holds for the sub-process of this. This is, I think, the case for basically everything we do scientifically, and it's also the case in literary studies. But we do not think about this in this way, and I would like now to turn to the question of computation and theory in order to show you how they do contribute or not contribute to the processes or the overall big process in this model here, right? So first thing, computation and theory in the case of computational literary studies. First, or it's majorly, I would say, now remarks about what computational literary studies are. So what are computational literary studies? I know, is anybody here aware of computational literary studies or even working in that? No, you a bit. Okay, great. So great that you do it and great that you don't. So I can explain it, try to explain it quickly to everybody. This is an overview. A group of people who are part of the big European computational literary studies infrastructure project. I forgot the beginning of the sentence. Anyway, this is a overview they have worked on when they tried to put together an overview of methods used in computational literary studies. And it's basically two things. It's general computational literary studies, so that's CLS, research aspects you can see now on top, which is, well, general things, but also authorship. So who has written texts or which texts are similar due to things. Genre, which means things like drama, novella, poetics, and so on. There's literary history, so explaining the big lines of history, development in literature. There's gender, and there's canonicity, which means the way certain texts become very famous and are being read in schools and so on. So they identify these major topics. They are, of course, are not comprehensive, but I think it's quite a good take to put them here on top. And then they have these introductions, and then you can see. So that's basically a way of also looking at it, how computational literary studies do work, because they provide always an introduction about the method, the focus. They talk about which texts to use for the analysis, so corpora. They do talk about additional information on it in text, so pre-processing, but also things like annotation and metadata enrichment. Then they do the analysis, which are typical, of course, different approaches people do apply for doing whatever they want to do. And there they talk about evaluation. So that's one way of putting computational literary studies as a field that covers majorly those aspects over there by going through more or less this workflow when doing that. Now, the second here is an overview about machine learning approaches in computational literary studies. My working group and our collaborators, or mainly our collaborators actually in Hamburg, Hans Hatzel and Chris Beeman did, and they looked into papers in computational literary studies that were published in 4 major venues in 1 year, and looked at those who did computational literary studies and also applied machine learning, because not every computational literary studies approach does that. What the outcome of that? So it was 40 texts out of more than 200, 40 papers, and these are the things people are using in these papers. So it's decision trees, it is neural networks, it's transformer-based stuff, of course, little surprisingly, but also a lot of other things. You may notice here that there's a lot of methods here that are not extremely up to date in computation, so in computer science anymore, but people do use them. And I hope that at the end of the talk, you will have an idea why they do that. I'm not going to say that now, but I'm going to present another thing, which is an overview of a similar overview. No, it's actually a different overview, but again, on methods in computational literary studies that has been done by a group that's part of the priority program that's also called Computational Literary Studies. And they just asked their project, so which methods do you use? Without saying which machine learning methods, so generally methods. And what turns out here is that they have, some of them said actually 6 in each case, qualitative analysis and also analysis of annotations. And the rest did some mixture, I would say, between what you see on the left-hand side and what I showed you before. So they said co-reference resolution or named entity recognition, stylometry, topic modeling, but also machine learning, development of classifiers, which of course basically can comprehend most of the things on the left, and so on. Okay, so computational literary studies, then what is it? I will present you now 2 takes on it, and in both I was involved. So it's not about blaming people, or if I want, I have to blame myself, but it's about showing that it has 2 sides or 2 possible perspectives on it. Right, here you don't have to read that. That's the application for the priority program in computational literary studies I was part of. And what did we say? We said, or the whole subtext of the application was, computational literary studies are firmly grounded in literary studies. So this is literary studies. Okay, now again, the paper I was talking about before, that is the paper with the overview about machine learning. What does this say? It says, CLS provide a test bed for natural language processing. So it's about language processing. The question is it computation or is it theory? What does matter in computational literary studies? Unclear. And I will try to show you what the point is, or it's maybe both, or should be both, by talking about computational narratology, which is actually my subfield of expertise. So that's a narrative theory and computation, basically. Right, what is computational narratology? Computational narratology is the study of narrative from the point of view of computation information processing. Here we go again. So This is, by the way, this is the entrance to computation and narratology from the handbook of narratology, so no computation in the handbook overall, but in this entry. It is also the only entry written by somebody who is not a narrative theory person, also very interesting. I mean, Interdisciplinary Humanities is somehow closely, of course, very connected to narrative stuff, but he's a computer scientist. Okay, so what's computation and narratology? It's the study of narrative from the point of view of computation and information processing. And indeed, I did a small research when I gave a keynote on the European narratology conference last year. I did a small research about narratology in NLP and NLP in narratology. And this is what came out. Narratology in computing, there's some things that explicitly relate to narratology or narrative theory when doing their things, and they take certain understandings of how texts work, how story evolves, what are parts of stories, all these things from narrative theory, and try to handle and tackle that computationally. So it's narratology in computing, one could say. But on the other hand, still sticking here to money, he also says a bit later, he differentiates between 3 types of computation and narratology. And here the literary theory or theory sneaks in again, I would say, because the other 2 are still very computationally oriented. But here he says there's also a humanities narratology sense, where we have a methodological instrument in the computation narratology approaches in the construction of narratological theories. This means this is also that it is used as something that provides insights for narrative theory. It is done computationally, but that's not the major point of it. Computation is just a means for doing that, right? Where in the other way, it's narratology is just a means to do computation, I would say. So here we have computation in narratology. Okay. So what about computation and narratology? Well, a more recent paper by Andrew Piper, Richard Danseau, and David Beman says this: computation and narratology is by and large divorced from the large body of theoretical work on narratives within the humanities, social, and cognitive sciences. So there is a gap, right? But still it is claiming, and it's also partly right in doing so, on both sides, people are claiming we're doing computation and narratology, or computation and narrative theory in computation, or whatever combination you can imagine makes sense, right? But as I said before, there's a gap in this process. And the gap can be seen when you look at how people do, or actually often do not, connect theory and textual features. So if we look at the process again, I would say this is also a typical process that is depicted here now in this workflow, input, process, output. One process is that you have to find a way from getting from theory to text by modeling things in between, which means by introducing a middle level also of abstraction, or by finding more specific ways that can in the end be something that can be found in the text. A typical example for that, or maybe not typical, but an example for that can be something like, we were working, as I said, on, or we are working on conflict. So if you have a theory on what a conflict is, so it's a probably social sciences theory, not a theory in a hard sense of theory in most cases, then how do you get from there to measure things in the text, which is it's the main goal of doing computational analysis, of course, if you do text analysis in computation, literary studies and beyond. So how do we get from theory to text? By modeling the theory to a certain extent, by understanding, for example, that what is in the theory, we use the theory about interpersonal conflicts from Friedrich Glasl, and who says, well, it's a combination of actors who experience some so what's the English word for that? Now it doesn't occur in German even to me. So there's non-fitting needs basically, and that they also realize that they do, or at least one of them does that. And we transpose this to, okay, we have the we transpose it to characters in text. These are the agents, and this non-agreement about things can be done in certain, or can be found in certain things. So we have a middle, a model of understanding what could be the thing we're looking for. Then we could go to the next point, namely looking at the text and say what specifically as patterns and indicators can be used for analyzing that. Okay, the point is that in computation narratology, in the sense of very much literary studies driven computation and narratology, this is being done. A lot of theory going on, a lot of modeling going on, and then there's some big jump to text and something is just counted, right? There's a famous paper by Franco Moretti from 2013 that's called operationalizing, I think, or the measurement of meaning, that has basically introduced the whole, or reintroduced the whole problem of operationalization into the field of digital humanities. And there he talks about character space, which is a concept from literary theory, talks about it and operationalize it. And then in the end, he just goes for counting words because that's the approximation he can come up with. It makes sense, but it's not perfectly convincing. But this is not to blame Moretti. This is to say, this is really difficult also to get through. Okay, on the other hand, we have current narrative theory or narratology in computing working like this. They just circumvent the model thing, right? They take something from theory in narrative, say, this is interesting, we go now for events, we go with story things, we go with characters, and they jump, or it's a detour or whatever you want it, and they just use the NLP model where they say, oh, that is feasible for that. We use that now. We have an algorithm that classes things that seems to be closely to what the people want to do. Here we go. Here we have the text. We can analyze actually the text with what we want. That's it, right? So the problem is the model is not really tackled in both cases, or it is a problem because in one case we have this not going from the model to the text. In the other case, we have the just missing out the model. I don't think it is on purpose, but this is what happens basically. The problem is that the NLP normally lacks intention, so the approaches don't really look at what the meaning of the concepts they work with is. So the theoretical conceptual foundations of these concepts. And the other problem is that computational narratology on the other side lacks measurement. They do not know how to measure the concepts they have, right? So the question is how to get from theory to text. And as I said before, we do not do that at the moment, I think. And that's also holding for literary theory generally and NLP. So computation literary studies, you could say. But I think it's also the same thing for other fields. I'm not talking about those because that's not my field of expertise. But I think it would be safe to say probably many humanities fields who do similar things have similar problems like the ones here. So what do we have to do? Basically this, we have to introduce both models into the process. We have to go, if you want to go from theory to text, the process in between is not only modeling on a conceptual level, but it's also modeling on a P level, or making sure that they are linked together. So the models we use in NLP with the models we use in the literary theory part, in order to really get a connection between theory and text. And what's the outcome of this is that if we have something that we find out about text with doing this, it is also validated, not in a statistical sense, but in an empirical conceptual sense, because we had made all those steps going from theory to really saying, and these are the exact measurements we do in the text, and because we don't have this interruption in between. So that's basically on a quite high level, high abstract level. I'm aware about this, but it's also very difficult to be less abstract and nevertheless say all these things in half an hour. That's on a very, very abstract level. I think one of the major problems we have in computational literary studies and beyond, or maybe in many interdisciplinary works where we have computation on one side, and I would even say something else on the other side. And depending on what the something else is, this in between gets more and more complicated. The more something else is used to formalization, quantification, all these things, the easier it tends to get, but it still is not easy. Also because the natural language processing models, they also probably are not perfectly fitting to these processes all the time, because people tend to think about something, say, oh, it seems like, it looks something like that can be tackled with whatever, a certain kind of classification algorithm, and they just take it, but they don't really make sure it really fits to the way people would cluster things with their disciplinary expertise. So not in detail, but from a conceptual way. So for going towards a more complex model, that's the last things I will be saying about this, is it is important to acknowledge that the whole thing, the whole input process output thing is a bit more complicated. So output still at this high level, of course, these are sub-processes again. But I would say it is okay to say output are the results, that's fine. For the input already, it's not just data, not just text analysis, as I said in the beginning, it's also the concepts, right? So the understandings of the phenomena I'm looking for, they have to be a part of the input, because they have to be the thing that connects the input to the output in the manner I tried to show before for the process. And that's also because here we have quite a huge process, right? So, and that's not something we came up with, or I came up with, but it's something it's adapted from Mari et al., who have a very interesting book that's called Measurement Across Sciences, and they proposed something like this, like a general model for doing measurements and the different steps of doing that, which are basically explication. So the can be definition, but must be somehow making explicit of the concepts you're looking for, in our case in texts. The operationalization, so the question, how can I put them into something that's measurable? Then the measurement, which is the process in this case. How can I measure this? What's an adequate measurement? And then also the calibration. So how can I make sense of what I did, right? Because people tend to just use numbers for something and calculate with them, but numbers sometimes don't mean nothing, right? So that's a bit of a problem. Especially, I don't know, I think it's also maybe a problem in computer science, but it definitely is a problem in digital humanities, where people also do things like using categories, different categories, which are conceptually different categories, not on a scale or something, providing them scalar values like 1 to 5, like Likert scales or something, and then use them for calculating. This does not make sense, basically, right? So, but still, we want to calculate this at some point. So the calibration must be there. And I think, to my knowledge, and this is also a thing I would like to ask you, to my knowledge, I'm aware only of one case in, I would say, in the humanities field, where the whole process has been done properly, right? Which is word embeddings, basically. Because they do formalize the theory of distributional semantics in a way that I think adheres to what people say in distributional semantics. A word is defined by its meaning. This famous saying of the meaning of a word is defined by the company it keeps. Then they come up with this idea of vectorizing words. Then they do that. There's different ways of vectorizing stuff and then calculating them, and then they calculate typically the similarities by using cosine measures, which is fine, I think. So in the end, you can say, okay, what we did here, or what the people who did that, basically, who started with word embeddings, they operationalized, or they were able to formulate a whole thing like this for the question of how to measure word similarity based on distributional semantics, understanding of meaning and similarities, but then translated into something that takes this up in a mathematical sound, I would say, way. Because what typically happens, this now is my last content slide here, is that people do one of the two things, at least in digital humanities, and especially in computation literary studies. There's the case of the theory-driven approaches. We have a heavily theory-based approach where validity is also provided to a certain extent, again, not statistical, but conceptual, through the establishment of a ground truth, like for annotations. They do a lot of annotation processes and iterations until they get to a stable point and make sure that what they have annotated is something that is also covered by the theoretical understanding they have been using. Typically, we have a missing link here between the operationalization and the computational process, and even more the calibration of the thing. Because what happens, we just take a machine learning algorithm and learn from the annotations to automate it, which is fine, because to a certain extent it works, but it's not the proper process that goes through the whole process and is sound in a stronger sense of the meaning. The second case is the more NLP, so the more natural language process model-driven case. And there we have NLP approaches for analysis of literary texts. They sometimes are also adapted, so that's fine. But here, validity, again, conceptual validity, is something that's a post-phase validity. So people look at things that they did and say, does it make sense or does it not make sense? That's not bad, but that's not really good either, right? So what we have here, we have a missing explication on operationalization of literary theory, plus the adaptation of the procedure, depends on how deep people go. In many cases, calibration is a problem. So basically, we have this line here, which is maybe something like a major gap, but I hope that I was able to show you that there's possible gaps around there that can be tackled also singularly, even though I cannot provide you yet the answer how to do that. That's something we want to do, or we're working at the moment. So to sum up, I tried to make the following points, I would say. I argued for literary text analysis possibly being an input process output workflow, even though that's maybe not the most natural thing to do, but still I think it's a very good way of putting it. Then I discussed the role of computation in theory, by the examples of computation, literary studies, and computation and narratology, trying to show you that it's basically in most cases an either or. People don't do both at the same time, and this is because of the gap in the process, that the linking between the major things that have to happen in a process is missing. And it's not only this simple linking that is missing, but it's a more complex situation we have to tackle by doing things like explication, operationalization, defining procedures, and also calibration with regard to the thing we're looking for. So that's it. Thank you for your attention.